Hello everyone, welcome back to the course Designing AI-driven Personalized and Adaptive Learning Environments. Myself Jyoti Shah. Today we are going to see the existing ITS. Already we have seen number of existing ITS. Today we will see ITS, that is MetaGuru. Now what is MetaGuru? What is the objective of this MetaGuru? MetaGuru usually it is used to stimulate metacognitive strategies through metacognitive prompts in circuit analysis problem solving. Now the question comes, what is metacognitive strategies and what is metacognitive prompts? So this is the major objective of MetaGuru, to design and development of this system. So what is metacognitive skills? Metacognitive skills refer to the self-regulation strategies that learners use during learning and problem solving. So it includes planning, monitoring, evaluation and reflection. So these kind of a metacognitive skills are fostered or are stimulated during the learning and problem solving. So these kind of a metacognitive skills can be stimulated using different tools. So here in this system, the metacognitive prompting is used as a tool. So what is this metacognitive prompting? So metacognitive prompting is an instructional strategy which is designed to support learners in activating their metacognitive skills. As I mentioned, metacognitive skills, that is planning, monitoring, evaluation and reflection within the computer-based learning environment. So MetaGuru, it is a computer-based learning environment which is used to stimulate metacognitive skills while students are learning and solving problems in circuit analysis, electrical engineering. Now we'll see the MetaGuru. This is a screenshot of a MetaGuru computer-based learning environment. You can see at the left side panel, there are different tools are available. For example, there is a highlight page, annotation page, simulator, task and calculator. So left panel, it is used for a different tools. Highlight page and annotation page. When students read any content and the same time if they do some highlight or annotation, they can go back to these pages and see what are the highlighted content or annotated content is there. So similarly, simulator is there where student can go and do the practical simulation of any kind of a circuit analysis. Now the next comes, that is a task. So whenever any system is designed, there is a task assigned to the students so that they have to do that task using this learning environment. So here the task is to solve the problems. That problems are a circuit analysis problem which is from the electrical engineering background. And the last option or the last tool is calculator, where an online calculator is available where student can do their calculations. Now we'll see the upper part of this learning environment. So in the upper part, this button is for the navigation. Learner can go and back from any kind of a pages. So this is a navigation button. Then the countdown timer is given, as we have seen in the previous learning environment, that is a meta tutor. There is also countdown timer where we can assign a particular time for the students and the student can monitor their remaining time. Here the annotator and highlighter, these tools are available. Using this tool, students can do the annotations and highlights. And the login, and this is the learning environment where the content is there. Now this is the screenshot of MetaGuru. In this session, we are going to see the demo of MetaGuru computer-based learning environment. What are the objectives of this learning environment? How the learning environment look like? How to use such kind of a learning environment? What are the different tasks are given? And what are the metacognitive prompts are given in this system? And how these prompts comes, when these prompts comes, and how to answer that prompts. So this is one of the learning environment we are going to see. So this is the link for the MetaGuru, metaguru.personaltutor.in. It is open to everyone. You can go to this site and you can use this link to use to operate MetaGuru. Okay, so for this, if you want to use this MetaGuru learning environment, you can request for the password in your discussion forum. We will provide you the password and you can access this learning environment. So let's see how it works. So metagurupersonaltutor.in, I'll provide the email ID and the password. Okay, after given the login and password, we will go to the introduction page or we'll go to the first title page. Here I am showing the learning environment page of administration, not the user side. We'll go to see the admin panel and we'll see how we can record the log data also. The interface of this learning environment is similar for user and for the admin panel. Now, this is the first title page where we reached after login and after login this page. So once you click to the circuit analysis, you will go to the learning material. So before going to the learning material, we'll go to the home page. So this is the home page of learning environment. In this learning environment, there is a one character which helps learner to learn problem solving using the metacognitive skills. So this character, the name of this character is Jazz and it works as a learning buddy. So this learning environment, this learning buddy helps you in problem solving using the metacognitive skills. So this character helps you to stimulate metacognitive skills. So this Jazz, the learning buddy, gives the metacognitive prompts at a different levels of the problem solving. So we will see how that problem solving works and how the prompts are given while learners are doing that problem solving and how they answers that problem, how they answers the metacognitive prompting. So in the home page, you can see the introduction of MetaGuru. Here, learner can read about the learning environment, how the learning environment works, how the different tools are there, how different features are there, and how these features are used. So at the first, learner will learn about this learning environment. So this is a one-page document where learner will get the details about this learning environment. Now there is a task button that after knowing how to use MetaGuru, students or learners will start solving the problems. So while solving the problems, there is a task button where students will get to know the different tasks. So there are 3 tasks are there: task 1, task 2 and task 3. To solve these problems, circuit analysis problem, there are some instructions are given to the learners that at a time they will solve one problem. So they can use provided learning materials. There are lots of learning materials available in this learning environment. So they can use the learning material while solving the problems. Now enter their solution. So they can solve their problems using pen and paper also, because in circuit analysis in electrical engineering, the learners need to draw the circuit diagrams. So to do that jugglery, they can use pen and pencil. But after solving that problems, they have to enter their solutions into the equivalent page, that is a solution page. Then they have to manage their time. As I mentioned, here the countdown timer is given. So to complete all these 3 tasks, we have given them 19 minutes. So within that 19 minutes, learners has to solve these 3 problems. Okay, so they have to use the countdown timer to track their progress, to track their time. one more instruction is that stay within this MetaGuru environment. So they can't use any external website, any GenAI for assistance. They have to use a MetaGuru. In MetaGuru, they have a learning material in the different forms like text, videos, then simulator, working problems. So they can use all kind of learning materials provided by this MetaGuru. They can use built-in tools also. As I mentioned, calculator is available, simulator is available, even the highlight and annotations buttons are also available. So they can use all the tools, they can use all the learning materials, and they have to solve the problems. Now we'll see the task. What these three tasks are there. So these three tasks are in a increasing difficult level. So task 1 is a comparatively simple task, task 2 is a comparatively a little bit difficult task, and task 3 is a difficult task. So we'll see what exactly this task is. The task is, in the learning environment, we have given them a simple circuit. We have given them a circuit diagram where number of resistors are there, number of loops are there, number of connections are there. So now they have to use any techniques, any circuit analysis theorem to solve these circuits, and the question is that they have to find out the equivalent circuit of this circuit. So equivalent circuit means that here in the problem we have given a complex circuit diagram. So from this complex circuit diagram, they have to find out the equivalent of that complex circuit diagrams to the simple circuit diagram. But that simple circuit should be the equivalent circuit. What is mean by simple circuit? Simple circuits where only one resistor is there, one source is there, and one load resistor is there. So in circuit analysis, learners has to solve this kind of a complex circuits into the equivalent simple circuits. So this is the task is given to the learners. So learners has to solve this problem. They can use the learning environment, they can use the learning material, and they can use the paper and pen to do some jugglery, because to solve such kind of a problems, they need to draw the circuits. So now there are prompts. In this environment, total 5 prompts are given. The prompts are for the orientation or identification of that problems. So to identify that problem, what given in that question and what to solve in that question, what exactly they have to solve that question. So at the start, the identification prompt is there, or the orientation prompt is there, where learners has to take a pause and think about the understanding of that problem. That is the first orientation prompt. Then second prompt is the planning prompt. So generally for the ill-structured problem solving, what is meant by ill-structured problem solving? Where the solution of the problem is open-ended. So there can be one question but number of answers and number of ways to solve that answer. But in well-structured problem solving, where the question is given, the answer is a fixed answer and the steps are fixed. So for one single question, there is a limited or one single answer. That is a well structured, typically in engineering education, well structured problems are there. So to solve this well structured problem, learner must know the domain knowledge as well as they must use the metacognitive skills to solve such problems. Though they are a well structured problem, but they might be complex, they might be difficult problem. So to solve such well structured problem, learner must use the metacognitive skills. Metacognitive skills, that is planning, monitoring, reflection, evaluation. Okay, so in this learning environment, we are fostering that metacognitive skills through the metacognitive prompts. So at a different level of a problem solving, we are giving the metacognitive prompts. So these metacognitive prompts are a reflective metacognitive prompts, means prompts are given and we are expected to respond that prompt. So the first prompt is orientation prompt, as I mentioned. So orientation prompt, learner has to respond to that orientation prompt before solving that problems. So while conducting the studies, or while when we ask learners to solve the problems, or when we give this task, we mention them that before solving the problems they have to respond to the orientation prompt as well as the planning prompt. Now we'll see exactly what the orientation prompt is there. As I mentioned, orientation prompt is basically to understand what the problem is there. So before solving that problem, the understanding of a problem is very important. So learner must understand the problem, what is given in the problem, and what exactly we have to solve in that problem. They must know that. So the orientation prompt is given. So orientation prompt, the prompt is like, do you understand the problem and what concepts do you think are needed to solve this problem? So this is the metacognitive prompt. This is orientation metacognitive prompts. So student has to take a pause, think about their understanding and think about what the question is. Do you understand the problem? If they understand the problem, they can mention that they understand the problem, they understood the problem, and the concept, what they think that are needed to solve this problem. So as an electrical engineering, after looking at the circuit, student from the first year or second year student must know what kind of techniques or theorems we can use to solve this problem, because this learning environment we have targeted for the second year engineering students, where already they have learned such kind of a circuit analysis problems. So to revise that circuit analysis problems, we have given this kind of a task. So many of the students know what type of a techniques we have to use here. So if after looking at the circuit, after looking the number of nodes, after looking number of connection, after looking at the sources, they must know or they can think what exactly which techniques are needed to solve this kind of a problems. It's not mandatory that students know everything. Sometimes student might know what kind of a concept they can use to solve this problem, or it is needed to solve this problem. So many of the times if learners don't know the answer of this prompt, they go back to the learning environment, and in the learning environment they look at the learning material. In the learning material they can look the previously solved sample problems or the different concept, different techniques, and then they can judge what concepts they are required to solve these kinds of problems. So this is the orientation prompt. So this orientation prompt makes learner to take a pause, think whether they understood that problem, and think about understanding of that problems, what exactly which techniques are needed to solve these problems. So this is the orientation problem. Now again, before solving the problem, one more prompt is there, that is the planning prompt. Planning prompt, once learner know about what kind of a techniques or what type of a techniques can be used to solve these problems, so they can plan accordingly that what strategies can you use to solve this problem. So what strategies? Strategy here it means what type of a techniques, equation, theorems you are going to use to solve this problem. So in this task, after looking at this task, this problem can be solved by a number of methods, number of circuit analysis theorems. So learner can plan which theorem they can use. So that is the planning prompt, and here the learner gives the answer of this question, means they are planning. So after this orientation and planning prompt, start they can start solving the problem and they can enter their answer. So while solving the problem, They can use paper and pen or without paper and pen. If they wanted to do, it's good, well and good, but they can use paper and pen to solve this kind of a jugglery, and they can find out the answers and they can put the answer in a solution page. So before going to the solution page or last page, before going to see the next prompt, we will see the learning material. What learning material is there and what is this learning environment is there. So as we have seen home page where the introduction of MetaGuru is there, task page where the 3 tasks are given, where the instructions are given and learners has to solve one task at a time. So while solving this task, they have to respond to the metacognitive prompts. Now the next tab that comes the learning material. So learning material. This MetaGuru, it is made for circuit analysis problem solving. So here we have given the 3 major chapters of a circuit analysis. So circuit analysis major chapters are basically it includes the 3 chapters. The first one, that basic concepts of circuits, which are the foundation for introducing fundamental concepts such as voltage, current, resistance in an electrical circuit. Then the next is the DC circuit, that is the direct current circuits. So this is easy to understand for the electrical engineering students. So DC circuits focused on direct current systems where the electric charge flows in one direction. To understanding of a voltage source, current source, resistors in a DC circuit is important. Now the third part comes, that is the theorems. So these contents typically included in the main chapter, that is the circuit analysis. So theorem, the last chapter, which gives the circuit theorems, that simply the analysis of a complex circuit. Analysis of a complex circuits. So these complex circuits can be these complex circuits can be analyzed and form a simple equivalent circuits. So for that equivalent circuit or for to simplification of that complex circuits, different theorems can be used. For example, Thevenin's theorem, Norton's theorem or superpositions theorems. So these theorems are mentioned in this learning environment. So in the learning environment, the basic concepts are also given. The DC circuit, that concepts are also given, that what is mean by electric charge, what is resistor, what is sources, what is the voltage source, what is the current source. So actually these 2 topics are the basic concepts of a circuit analysis, and the third chapter where the actual task is depend on this third chapter. So these are the learning material, basic concepts. Under this basic concept, these topics are there. Under the DC circuits, these topics are there, and theorems, again different topics are there. So we'll see just how the learning material is used here. So while accessing this learning material, either video or a text, again one metacognitive prompt pops up. That metacognitive prompt pops indicates that is this content relevant to the task you are working on. So if learner randomly selects any learning material, and in that learning material the prompt comes to check to or to prompt to the learners that whether this learning material you are checking, whether this content relevant to your task you are working on. If it is yes, then learner can put yes, or if it is no, they can put no. It means that it stimulates metacognitive monitoring, means learners to check the relevant content to that task, not the irrelevant for that task. So learner can put yes or no and they can submit and they can move to the learning environment. So this is the learning material where the source is there. In MetaGuru, learning material provides in a different form. This is the text form where the learning material or the concepts are given in the text form, where the solved examples are also given, and along with this solved examples, along with this explanation, some Self-assessment questions are also given. So learner can assess their knowledge by this self-assessment question. So at the end of the content or at the middle of that content, some self-assessment questions have added. So for example, here one question is added, student can give the answer to this problem. Here the feedback is also given. If the answer is wrong, the constructive feedback is given, that for example in circuit diagram, how is an independent source typically represent, whether it stores diamond shape or zigzag or rectangle or a circle shape. If you select the wrong answer, the system will give you the constructive feedback. The constructive feedback is that the diamond shape symbol, if you click on the diamond shape, it gives you the feedback that diamond shape symbol in circuit diagram represents dependent source, not the independent source. So this type of a constructive feedbacks are given while it is right answer or while it is wrong answer. So these self-assessment questions are there in each and every learning material, the content, whether it is a basic concepts or whether it is a theorems. So here at the right top, right bottom corner, there is a next button. This is to navigate to the next learning material. If you go to next, we can go to the video material. So in this learning material, the learning material comes in a different forms, as I mentioned, either text or videos. So same kind of learning material we will get in video form. So in the video also, learner can watch these videos. They can seek, pause this video. They can forward, backward these videos, and they can learn the learning material while they solving the problems. Here in this learning material, in this video also, we have put the self-assessment questions where student can answer the questions and try to find out whether they understand that concepts or not. So these kind of questions, self-assessment questions are given. So learner can go previous and next to this learning material. They can navigate to the different contents or they can directly go to the learning material. So in the learning material, this is the table of content. Through this table of content also, they can choose their learning material, whether it is video or a reading. So some learners can learn the content with video, some learner can learn the content by reading. So this is a choice for the learners. The same kind of a content is there which is in the form of video and reading. So they can just go to the reading material, or if they want to go to the writing material, they can go. So in between, the metacognitive monitoring prompt is there. So metacognitive monitoring prompt help them to monitor whether they are accessing the learning material, whether that learning material it is relevant or not. Because in most of the times when any learner starts learning something from that computer based learning environment, there is a chance that learner may learn the irrelevant to that task. So this prompt is used to monitoring. Now, while reading this content, we have a different tools. These are the different tools at the topmost, that is annotation and highlight button. So through this annotation, learner can do the annotation. For example, from this content source source transformation. In the source transformation, if learner wants to annotate this sentence, they can annotate that this is very important content. They can mention that this content is important. They can annotate that, or they can highlight this content. If they wanted to highlight some content, they can do the highlight. So this is the highlight button. As I have activated highlight button, when I want to highlight some content, or if I want to do the annotation, we can do the annotation. So while reading this material, student or learner can do annotation or highlight. Now, annotation and highlight, it is used for a reading purpose, or learner can monitor their understanding. They can go back to this highlight page or annotation page where they found that this material is important for their task. So they can go back to the highlight page and they can see which content they have highlighted right now. So they can check the highlighted content at which page, which learning content they have highlighted, which part of that learning environment, as well as the annotation, in which article or in which learning content, how much text they have selected, and for that text what type of a comments they have given. Comments, they can put the important, or they can put that is a least important. So these kind of a comments or their understanding they can mention, and they can go back and check this kind of annotations. Now again at the left side you can see the two more tools are there. One is a calculator, the simple calculation they can do, and another part is the simulator. Here the circuit simulator is used. In a circuit simulator, the tutorial is also given, so learner can go to this video, they can watch this video for the tutorial purpose. They can learn how to use the simulator, and they can use this simulator to evaluate their answer. They can analyze their circuit. So in this simulator, learners can select their component, they can draw their circuit. Here the extra components are given, they can drag and drop that component, and they can make their own circuit, and they analyze their circuit. For example, for this circuit, if they wanted to check, or will simply remove this previous one. New blank circuit. Here in the new blank circuit, learners can draw their own circuit. For example, here I am drawing my own circuit. Here they can draw their own circuit, and they can check the voltage and current. For example, if I wanted to check the voltage and current of this line, this voltage source, I can see the current is 3 milliampere and voltage is 5 milliampere. So at this right bottom corner, we can see the value of these components. If I take my mouse cursor to the voltage source, I'll get the information about this voltage source at the right bottom corner. If I put on this equipment or component, I can see the values of this component, values, the current sources at the right bottom corner. So this is the circuit simulator. It is very useful while solving any circuit analysis problems. Learner can go back to the simulator, they can draw their own circuit, they can draw their own circuit and find out or analyze that circuit through the simulator. Sometimes this circuit analysis simulation, it is used to evaluate their answers. So whatever the answers are getting while solving the problems, they can recheck that answer with the simulator. So this simulator is available. Now so this learning environment learner can use while solving the problems. After solving the problems, once they wanted to enter the answer, they can go back, they can come back to the solution page, and they can enter their answer for this particular question. So before entering the answer, again there is a metacognitive prompt. That prompt is an evaluation prompt. So before entering the answer, before learner come to the final answer, there is a evaluation metacognitive skills, where learner has to evaluate their answer, learner has to check their answer. So rechecking that answer, evaluating their own answer is very important. Most of the times learners spontaneously not use this kind of a metacognitive skills. So metacognitive prompts help them, or it stimulate their evaluation skill, so that they go back and evaluate their answers. So for this kind of a metacognitive prompt, we have given the buttons yes and no. So if they have checked their answer, they can say yes. If they have not, they can go back and check their answer. So here also we have given the feedback that they can use simulator to evaluate their answer, and if they have evaluated their answer, that is well and good, they can enter their answer. So after solving that problem, they can write their answer here. So write your answer here including the unit of components. So they have to enter the unit of the components. So submit that answer, and at the end there is a reflection. So once the problem solving is done, each learner has to take a pause and give the reflection about that problem solving or about that learning, to memorize, to get to know the process of that problem solving. So that's why the last metacognitive prompt is given, that is for the reflection prompt. It stimulates learners to take a pause and give the reflection. So here prompt is given, summarize what you have learned. So while solving this problem, means while solving the problem, while accessing the learning material, what is your understanding is there, what you have exactly learned, the learners has to write that summary. So after submitting this, you can go to the task 2. The same way learner has to solve the task 2 and the task 3. Only thing is that these tasks, the difficulty level increases from task 1, task 2 and task 3. The same kinds of prompts have asked in all the 3 tasks. So this is a MetaGuru. MetaGuru, it is a computer-based learning environment. It is used to stimulate metacognitive prompts. It is used to stimulate metacognitive strategies or metacognitive skills through the metacognitive prompts, and some self-assessment questions are given in this learning environment with the constructive feedback, and the different prompts are given and learner has to respond that prompt. Now in future we are planning to give the personalized feedback to this prompt. So whatever learners give the response to the prompt, based on their responses, we are planning to give the feedback to that response. So hope you understood this kind of a learning environment which is used for a circuit analysis problem solving. In the PPT, I have given the link of this learning environment. This learning environment is totally open source. Everyone can use and see how these prompts are used and how this prompt helps learner to learn or to stimulate metacognitive skills. And if you want a password in your discussion forum, you can ask for the password. We'll provide you and you can go through this MetaGuru. Hope you understand and you enjoyed the MetaGuru personal tutoring. Thank you.